Thank you very much, Ruben. Yeah, so Hans, I just introduced you. Your webcam looks black. I don't know if you're...
Oh, I don't understand why. Okay, then I have to do without.
That's okay, no worries. So our next speaker is Hans Knudsen from Compil, and he will talk about the thermoforming of bio-based thermoplastics that were just introduced by Ruben just now. Just for any questions for Ruben will be asked at the end of Hans' talk, and we will do a dual combined FAQ, if that's okay. Thanks. I give you the lead, Hans, and I just give you control as well.
Yeah. Thank you. I just have to correct you a little bit, and you have to have your money back on your geographical skills. We are in Scandinavia. We are actually in Denmark and not in the Netherlands. So.
My deepest apologies. I'm terrible at geography, and thanks for illustrating this. And my apologies.
Yeah. Okay. I'm going to talk about the thermoforming of the bio-based thermoplastics that we get from Centric Bell. And okay, oh sorry, it's a bit quick. Can I go back? Okay, okay, doesn't matter. To have an idea on how long time it actually takes to impregnate the materials, you can use Dorsey's law as giving you a thumb. Dorsey's law, I don't know what there it was. Yeah, okay, gives a bit fast. Gives you a time depending on that, and you can see in the actual Dorsey's law that was before. There should be a way to get back. Ah, okay, won't help me.
Sorry, Hans, if you want, I can move the slides for you if you're struggling.
Yeah, because here it goes a bit too fast. So could you go back a bit?
Yeah, no problem. Just give me a sec. Yeah. This one?
Okay, this one, yeah. The time depends on the system you're actually working on, but it's mainly the permeability of the system at the temperature working at, the polymers and so on. But actually, what's important is to know that the distance the polymer has to flow squared is actually a very important thing, and that's why we are using combing yarns here, because then you are getting a very low distance that you have to move the polymers. And then you see the higher pressure you put on, the faster it will go as well. But that's only linear to the pressure. So those two are the most important things when you have chosen your system. Next one, please. There's two ways we are going to work on this one. One is vacuum consolidation, also called vacuum back consolidation. Yeah, it's vacuum back consolidation is a very simple, flexible, and easy process to consolidate your parts in. It works here with a low pressure, and it takes a long time, as you saw from the equation you just saw before. But it's very easy. You have your tool, you have some release on your tooling, and you put some material in it, and you put a release or just a vacuum bag on it and drag vacuum on it, and then that's more or less it. You heat it up, and afterwards you can take it out again. So next one, please. So you more or less say it's like baking a cake at home. You have a recipe where you put your layer up of materials, then you bake it at the time you have in the recipe, and then the most important thing here is that you actually make the measurement on the materials in your tooling, not of the oven temperature or anything else, but is on the materials. And one important thing is that you can actually incorporate drying in this process, so you don't have to pre-dry materials if that's necessary, which is often is when you are talking about biomaterials. Next one. Here there you have a real recording of a thick laminate that we made. But I would like to cut it down into sections, and then you can take the next one. Because the first one, as I said, you can incorporate is drying. And here you see we put it on a temperature of 160 degrees for this system here. And that's the first red curve you see. And as this one is a very thick laminate, you could see that the other lower red curve, how long time it actually takes to gain the same temperature of the materials as you have put on the outside. But the very important thing here is actually the black one. The black is the vacuum level, and you see the vacuum level goes up and actually down here very much, because here you are cooking off boiling off the water. So you see how long time it actually takes for the water to boil off, even that. And it's like 2 hours on this one. This laminate was 32 millimeters thick, so it really was taking a lot up. But you see how much the vacuum curve actually changes. So it is very important on this material to keep do the drying up front. Next one, please. Here you actually have the wetting out of the fibers. The fiber, you can see, need to be wetted out, so you have to go above the melting point of the polymer because you have to move it. And here it goes up, and again you can see, due to the thick laminate we have here, that we actually are running like 45 minutes after the outer layer temperature. So, and you have to take a time, as according to the equation as shown in the beginning, that will take some time before you have moved your polymer throughout all the filaments. And the vacuum level, you have to make sure that you are keeping nice in the same flat at the bottom here. Next one, please. And then the cooling down. This is many cases the overlooked part of the process, because here's actually where you determine the properties of your laminate afterwards. Because crystallinity is determined by the time you are in the crystallization zone, and this is dependent on the polymer, of course, where that is. But you have to take time enough, or not take time enough if you want to have crystallized or not so crystallized materials when you are finished. But when you are having a thick laminate like this one, then it's also good to run over the melting point very slow, so that you are actually getting a very uniform material throughout the solidifying process. So that's why you also see a knick like a chair in this one, where the melting point is, and before we go down to those temperatures. And again, the vacuum level is constant at the bottom. That's very important. So thank you. Next one. This is showing the system that we have been doing, and this system can run up to 350 degrees. So we are can process a big range of materials on this system. Next one. So the pros on this vacuum concentration process is it's a very easy process. It's flexible. It can be low cost, but it also means that it's for low numbers. And the cons is, as I said, it's a very slow process and not easy to automate. In this case, you can do some, but yeah. So for these numbers we are having here, that we are going on to the next process. Next picture, please. The press consolidation. Oh, no. the purpose is like here we are melting the matrix and force it to bed out the filaments, like in the vacuum consolidation. But there's many ways we can do this. Next one. But we have chosen here a 4-step system where you have in all the steps here you can have decide on the time you are in each of them freely. Next one. The system is first one is that you lay up on a transport unit the layup that you have designed. Next one. The second one, you actually go into the heating. We have a separate heating system here because we have the temperatures that you can control at a steady state. The pressure you can put on the laminate for the impregnation, and also you can have vacuum put on if you have a very sensitive system here. So you can also decide which percent of vacuum you will going to do. And the reason for having this steady temperature here is that you are only heating the laminate and not heating the mold, or have to cool it down afterwards. Next one, please. As you see here, we have a very fast heating of the laminates because it comes in like room temperature, and after like 40 seconds, it's on high the temperature you have put on. So that is going fast, not like minutes or hours like in the vacuum consolidation process, but here you are on a very fast process. Next one, please. The third step is where you actually form and cool down the layout. So here that you are having your tooling, and you're coming with your melted material for consolidation, so you can form it and you can actually press it and cool it down at the same time. So next one. So you can just take it out and remove it afterwards. Next one. Here you actually see the machine as we have designed and been running these trials on, and here it's running from the right hand side to the left hand side. So yeah, next one. So as said, the system only heats up the laminate with minimize the energy you have to put into the things, but also means that here you can make tooling of different materials, and we have been using wood, POM, or high molecular weight polyethylene. So we see those 3 different toolings, and they've been working very well with our materials. So next one. But we also, to be able to do these things, it's not only the tooling or the system, but you also have to transport the materials. And we build up your transport unit where you can pre-mount your laminate, and this will say that you can be it offline and you will automate this. And then you can also control the tension and other things on the layup, and easy to transport. So next one. And there you see the formed materials after the molding, and then this one is a standard size. We have not minimized the materials because you can actually design it so that you don't use so much materials as here, but this is a flexible unit that you can use for many different applications. Next one. So the press consolidation here is that it's fast, can be optimized. We are low on energy consumption, and it's for higher numbers. It requires a lot more systems to work together. And it's also more expensive than the vacuum tooling, and it also requires that you are designing your tools very carefully here. Okay, next one. So, but the objective was for us to produce foot soles of the self-reinforced PLA, and we have done so, as you can see here. And in the next one, you actually can see that we have been able to get it mounted and also it is in testing by the company who designed this. So we established the process, and yeah, we also have manufactured parts. Thank you.